Jayita, Javeed, am I audible or is my audio too noisy?
Yes. Yes, Ram.
Yes, you're audible.
This is going to be confusing. Okay, fine.
Jayita, are you happy to go first?
Sorry, I couldn't get you. There's a bit of disturbance.
I'm sorry? Jayita, are you happy to go first? I'm not sure if you could hear me or not.
Yes, I can hear you. There's a bit of disturbance from your end.
Okay, yeah, sorry. Yeah, if you can go first, I think that would be great. Can you share your screen? Yeah, Jayita, can you please go first?
Okay, sure. Just give me a minute. I'll plug in my headphones. Am I audible?
Yeah, if you're audible, please go ahead. The talk should be 10 minutes long. So, yeah.
Am I audible, visible? Okay, let me share up. Let me know if it's visible. Okay, yeah. So hello everyone. Thank you for inviting me over to FOSS United. And yeah, sorry I couldn't be in person, but thanks to the team for arranging this virtually. At any point in time, if my technical glitches appear, do feel free to stop me. I am although do share it via voice because I won't be able to see the live stream screen at the moment. Okay, on that note, I am sure you guys had lunch and might be feeling hungry at this point in time. So today we are going to cook some halwa with a blend of tech in it, of course. So we're going to see how we can eradicate hallucinations that appear into multimodal LLMs. And there's a lot of jargons that we see here. We'll try to mystify each of them one by one. Uh, so first up is the multimodal LLMs that we have. Of course, I'm sure most of you are acquainted with it. So multimodal means that the different kinds of modalities that are present, apart from just the text, we now have the image and audio, video, and all kinds of different kinds of modalities that we can feed it to these days, LLMs to the system. And that's how we get responses out in different formats as well. So I'm sure you guys are smart enough to have tried out all those auto code completions. Maybe you just give it to your code files, you upload your code files, and you wanted to debug it where it is giving the errors. Or it might be that if you're a student, you might be wanting to give out answers on your assessments. So I don't know how far do you get correct answers, and that's where it brings us to hallucinations, which is pretty fancy name under the hood, doing some convincing fancy lies. That's what hallucination is. So if you want to understand it practically, there's an example onto the next slide. Apart from that, in your real life, if you think about it, that Tinder bot that you think is a girl or a boy could be just a restaurant owner wanting you to come over and have some coffee sales up. So hallucinations in terms of LLMs is when you ask it, maybe an example of is say, is 9.11 greater than 9.9, and it very convincingly says that yes, it is. Whereas you go back to your consensus and think that no, I go back to class 4, fourth standard mathematics, where we know the decimal system. So it comes up with our consensus that the LLM is going to see some is saying some wrong answers to us. So this is a very practical example that I had to correlate with halwa. Uh, so she who should not be named makes halwa out of my hard-earned money, and I think about the government benefits no longer. Although, anyways, that's just to give you an example what hallucination is of the tax benefits. So there are various reasons as to why hallucinations in LLMs can happen. One could be that it has not seen that particular pattern or that particular data was into the training set when the model was trained. That could be one of the factors. Or say there is certain kind of bias in the data. So if I have a certain greater amount of data and have a lesser amount of data for two categories, so its model predictions will always go to the greater one. And thirdly, there are certain things that while inferencing or while I am trying to generate the answer, I could also get to the model to answer it incorrectly. So those are certain ways that certain causes as to why hallucination happens, and this meme might show you one of them. So there are certain ways to tackle these common day hallucinations. So prompting is one of the ways. So if you remember the example that I said that 9.11 is greater than 9.9, and the model says yes, and then you reprompt it again, that saying that no, it's not correct. You should think about it, and model again tries to recollect the what is correct and what is wrong, and then it tries to analyze it and say that maybe you want to go back to decimal systems and think about it, and it somehow might say you the correct answer. There is RAG, retrieval augmented generation. So you don't want the data to come out of anything and everything that has gone into the training the model. You just want it to restrict to your particular data. Say if you are a retail, if you are into retail and you want to build up an e-commerce website and you want a FAQ chatbot to be built, so you restrict it to the FAQ answers of your system only. And because these days LLMs say that most of these closed source models that we have say that they are training entire internet of data. But what does that exactly mean? We do not know. What exact internet data is going into these systems? We do not know. So there are some other ways to do it as well. There is reinforcement learning human feedback. So what that means is that whenever the output comes up out of a system and output comes up out of a model, you have a scoring system. If it is a correct answer you think is a correct answer, you score it higher. You think it's a wrong answer, you score it to a lower score, and that way the model learns that how to correctly predict outputs. There is also fine tuning. So say for example I want a system to build which exactly sounds like me. So I have all over the years I have collected a data set over how do I sound, and that data set I train it using some LLM or a speech to text models, and that way it comes out with the output of exactly how I speak. It will come out to be like that. There is also certain parameter tuning that you can do. So there is, if you have ever used an API into any LLM call, you will see that there are certain attributes coming in like top K, top P, or temperature. All of these you can tune it and you can experiment with it, that which are these factors affecting the more towards the correct answers, or how skewable the answer is. So these are certain ways how you can go about it. So, welcome to the multiverse of hallucinations. There are different kinds of hallucinations which the researchers have come up over the years, and this is specific to vision language tasks. I am not going into much into more. Today we are going to focus onto vision language tasks, specifically vision language, what the vision language models do. So given say an image and given an input text as to what the image shows or describe the image, these kinds of prompts along with the image, what is the model outputting you is what we are more interested to for today's session. So for example, say the first one if we have here is movement hallucination. So here if you see it's some people going on to skiing, and the model says that they are going down the slope but if you see they are in the image, we cannot say whether it is a movement or it is just standing still. So that's where model might get hallucinated, because skiing is a movement activity, we know. There is emotion hallucination. So if you have a pet in your house, you would associate that some affection, it should look up to you in some affectionate. But here if you see it's the someone is feeding the cat, and cats are known for not giving attention. So there is spatial relation hallucination, which here in this image, if you see, it predicts that there is a green light at the top and the red light at the bottom. So that's not correct. We all know that the red, gray, yellow, and then the green comes up. So this is where it goes wrong into where exactly the object is in an image. There is non-existent object. This is a birthday celebration going on, and the model assumes that there will be balloons and streamers present in there, but in fact it is not the case. So there is today specifically we'll be focusing on object attribute hallucination. So we'll see that in the coming up slides. So here it says that there is a cat sitting on a table and the table is made of wood. We do not know that, right? But since the fence behind it is made of wood, the model assumes that the table would also be made of wood. Physical state hallucination is something like if you see and there are oranges and there is a chocolate cake here, model assumes that the cake is made of oranges, but we do not have any proof of that happening. So today particularly we are going to focus on object hallucinations that we saw in the previous, which is a subset of what we saw in the previous slide. So it very specifically says that if whenever you question a model and a vision language model to output something which is not in the image, and it comes out with that output. So for example, if you see here in the first one, there are utensils present, and model says that there is a toothpick, because usually we would associate utensils with toothpicks, but in general it is a Lego. So it has not seen examples of utensils and Legos together. That's where it says the wrong answer. So here it was a comparison between the HALVA model and the Lava v1.5 model. Similarly, the next one also in the right hand side says that there is a cake present, and it asks, the user asks that is there a tie in the image, but the Lava model says yes, the HALVA model says no. So as to why this happens is usually there would be a groom and a bride, and the groom is wearing a tie, so it associates that because it has seen that pattern in its training data. So we'll see how some prior work has been done to tackle these hallucinations. There are uh, three parts in which researchers have tried to tackle it out. The very first one is at the inference level. There is a framework of Woodpecker which tries to address this problem. So given an image, so this is the image that is being fed, and the query is to describe the image, and the model very particularly outputs as to where the exact objects come in and how they are placed at each as a whole into the whole picture. So there are 4 steps that this process follows. One is the key concept extractions, which is that what are the exact objects present in this image. So here, if you see, there are some dustbins and there is some cycles present. So that is what it is trying to come up with. And then it will try to formulate some questions as to how many cycles are there or how many trash bins are there. So those kinds of questions, where exactly they are located, and where exactly they are located, it will also try to get the bounding boxes of coordinates of where exactly in the image this particular object is coming. And with that, it will try to accumulate the entire things that it has tried to decode and tried to iteratively come up with to formulate in one whole sentence. And that's how this works. Now the problem with this kind of systems is that it will to an extent give you proper answers, try to dissimulate the hallucination, but it is very infra specific. What I mean by that is it is pretty time and cost intrinsic, because time, as we all know, that it is trying to iteratively come up with the answers, and in the back end there is some decoding going on, so it will take time, and that is what we do not want. So the next method is pre-training. For pre-training, there is a process called hallucination augmented contrastive learning, which works in a way that there are certain positive examples and there are certain negative examples. So contrastive learning tries to teach the model through negative instructions. So here, if you see in this diagram, there are these positive examples and there are these negative examples. And with that, it tries to train the model and teach it out that what the correct answer should be and what the wrong answers are. So here again there is a challenge in this method as well, which is we would need a pretty big training set, say for example 500,000, greater than that number maybe. So that is pretty much a big number that we always might not get into some specific task specific example use cases that we might want to execute. So that is one challenge with these kinds of systems. Again, there is the last and the third kind of it is fine tuning, or HADPO, hallucination aware direct precision. Hallucination aware direct preference optimization. So this tuning method works in a way that it will try to either do precision optimization or take some human feedback to come up with the correct answer. So there are again 4 stages to it. Again, you feed an image, you prompt it to describe it, and the model will give you some kind of hallucinated answer. So you have a system where you detect the hallucination and try to correct it out. The third part is where you do style consistency data augmentation, which is like, say for example, I see a sentence that I have a fish and the cat ate it. So if I say cat ate it and I have a fish, doesn't make sense, right? The style consistency should be maintained in natural language processing to make meaningful output. So that's what the third step is about. And lastly, the hallucination mitigation happens through precision, direct precision optimization. The maximum likelihood would be predicted for the corrected answers. So that's how this method works. The problem with this kind of method again is that although fine tuning is a better approach than the inference and pre-training methods, the challenge here is that it will I'm sorry, it will it will degrade the performance of its base model, and although it may give me non-hallucinated answers, the base model performance goes down and the accuracy may go down. So that is not what we target to do. We do want something which is not data intrinsic to train, but at the moment it does not even which gives us non-hallucinated answers, but at the moment that it also retains the performance of the base model and never deteriorates from that. So it's like saying the situation of Sab bhi mar jaye or Lathi bhi na tute. So we want that to happen. And for that, I know we are still not coming into Halva, but to know Halva, there are two parts to it. We'll learn the two things and then we'll finally make our Halva today. So there is direct data augmented phrase level alignment. So we are saying that instead of training the entire sentence, why don't we train certain phrases or certain tokens in the model which are hallucinated? Is there any?
Yeah, hi Jayita, I'm sorry. Yeah, so like this is supposed to be a 10-minute talk and you wrap up.
Sorry, I can't hear you.
Uh,
Okay, I will wrap up. Yeah, I will just take 5-10 minutes more and I'll wrap up. Yeah. Okay, so phrase level alignment is somewhere we are talking about why don't we just change certain phrases or certain tokens in the model to, instead of training the entire sentence or the paragraph, we change only certain parts of it to for the model to detect which is the correct and which is the wrong part of it. And to do that, why do we need to collect data or have it in a very have to do manual intrinsic work? Why don't we have generative data augmentation, so that itself we through tuning the ground truth of the corrected output, we get to know what is the wrong output. So if you see here, the example is a young man in a white shirt and blue jeans is skateboarding. So the hallucinated version would be a young woman in a black dress and red sneakers. So certain words are tweaked and the model tries to learn out of that. So there is a phrase level loss to it for the model to try to learn about it. In interest of time, I will try to skip that up. And so this is the whole scenario of Halva, the direct the phrase level loss along with the data augmentation. The When you converge these two techniques to build a application which is called halva, hallucination attenuated language and vision assistant, so that will be able to mitigate your hallucination, at the same time prefer your model not to diverge much from its base model as well. So there are certain calculations, and in interest of time, I would like to skip it out. But all of this is present in the paper. If you're interested, do read the research paper from Google. They released it. It's very interesting to see how this method is becoming a better way than the existing methods. And if you are more interested, there is a pseudo code available to it. All those calculations that I just showed in the previous slides will be covered in this whole implementation. So it's very simple code. If you know PyTorch, it's very simple to just plug up uh, some uh, some systems that you do. And there are certain evaluation techniques as to why do they claim it. They have given it in their paper. They have discussed it thoroughly as to how this method works and how it is more evaluated than the existing ones. The first A part is where the it compares with a fine tuning methodology compared to other existing fine tuning techniques into vision question answering. And the second one is the KL divergence loss that they have, regularization, sorry, that they have, and how that proves to be a better approach than the existing systems. Again, there is certain performance evaluations benchmarks. So into when you have a image description task, the captioning could go wrong, and so there are certain already benchmarks set up where it tries to predict that what are the number of negative things, or what are the elements that are non-existent but the model tries to predict it. So those kinds of benchmarks and data sets are already present, and halva was evaluated on top of it and proved to be a better one than the existing lava models that are present. And these are some of the references. If you want to go through, all of it is present in internet, and you can just go and research about it and try to implement. And lastly, if there's any if you want to wish to know about me, do reach out to me on LinkedIn. If you have any questions, more than happy to answer. These are some of the activities that I do as a day job, and from my 5 to 9 and 9 to 5 tasks. And on that note, happy halva days to you. It's winter and inevitable to not have a bite of halva. So I hope you like the session, and thank you to FOSS United. I'll stop sharing and hand over to the next presenter.
Yeah, thank you, Jayita. I hope you've shared your uh, contact details with the audience. We'll share your slides with the people, so please do share your slides.
Absolutely.
This
audio.
is for the
Live stream. If you want to share something on through that way, there's a Jitsi link that I share,
Okay.
and then we can take it.
No need. This is
No
just
need?
a text-based slides.
Perfect.
I'll just like hold the laptop.
Yeah, perfect. Sounds good. There's one speaker. One you can turn down. Maybe one more going on. Monitor so that they can connect and no. Okay, so we don't have to ask people to. Yeah. If you can please bring your chairs this way, I think that will be easier. Be easier to listen in.
I asked you what you did not let us process
So, hey guys, everyone settled, or you want to have some more time to get settled? Everyone okay? Okay. So myself, I'm Akhil. I'm working as a software engineer in DBS. I started my career like way back in 2017, and it's a pretty good amount of time that I spent in software industry. But apart from work, I also have my own interests in open source. So I contribute to like many open source projects in Rust and Zec. So today I'm going to talk about interesting thing that I've been like doing since couple of months, where I've turned my old laptop into a home server, and instead of like me using Google Photos to backup, I use my own system, which acts as a backup system, and also parallelly I host like couple of services where I can access anywhere from internet. Okay, so today I'm going to like talk about how I have set up the home server and how I'm like backing up my photos from mobile and then syncing it to the laptop. That's there. Okay. So this is like the if a screen would have been there, a bigger screen would have been like much more interesting. But this is the starting of my slide where it says free Google Photos, but it's not exactly Google, but we will be using an open source application to back up pictures for free. If you have your system, you can just use it. So when this itch has started, so when I cross the limit of my Google space, which is like 15 GB at max, then Google asked me to like pay some 1,500 rupees a year, which I said like, dude, like no, I don't. Then I'm a software engineer, so I should be like or managing my everything because I'm a software developer. Sorry. Oh, okay. So when I crossed the limit, and also like when I found there is an open source application called Image, then I thought, why can't I explore Image and then see if it's possible, which can be an alternate for Google Pictures. Then I started moving, as in started experimenting on my old server, which is a simple laptop, which is a 10-year-old laptop and a 13-year-old processor. So currently it's serving 500 GB of photos. So let's like start how the journey had begun. So first thing is all about the hardware. So it contained Windows. Then I simply like formatted it because I didn't like Windows, and then I burnt a Debian OS image onto an USB and then installed it. And during the like on the left side, if you see, these are the steps that I have like followed for setting up. And on the right side, whatever the black background that you're seeing, these are the kind of like problems that I faced during the setup. So it was a headless operating system. As in, if you install any operating system, you connect to a monitor, you have a GUI, right? Graphical user interface. But this is completely headless, as in it doesn't contain any GUI because the laptop is treated to be a simple server. So it just has a terminal interface where I can access through SSH. So it's a completely headless server. I mean headless OS that I installed, and in the process, partitioning the hard disk was a bit of a challenge. So that I faced, and other thing is like setting up the Wi-Fi configuration, because in GUI you can just like simply go to that Wi-Fi settings option and then just enter the SSID and everything. Even you need not enter the SSID, but if it scans properly, then it auto pops up. But configuring it through a configuration file was a bit difficult. So I had went through some trial and error experiments, but finally I was able to like succeed. So this was like from the hardware point of view, and now coming to like the connectivity. So my objective was that not only I should be able to like access the system from my local network, but also like from the internet. So security was like paramount for me. So when I want to like connect to the system through SSH, so it should be only possible through the local network, but not from the outside. So if you see, SSH was only possible through local network, and also it was like passwordless authentication. So using the private public key based setup, I like configured my system not to accept any password based authentication, but only through through public and private key authentication. And the other thing is that if I want to access from internet, only port 443 should be accessible. But for that to happen, now I had to like go to my router. So in the router, like I configured that if any traffic is coming from outside to this particular system, then only the network traffic where it wants to access port 443, only that traffic should be allowed, whereas the other ports traffic will be like disabled. So that firewall was configured in the Geo router, and then apart from this, like to resolve the domain name. As in, it's not like I'm directly accessing through IP address, but I would be like using through a domain name, right? So I need to like resolve that domain name to a specific IP address. So for that, I'm using Cloudflare DNS service, which is kind of a free service where anyone can just like go and sign up. So there you can just configure your domain name and to which IP address it should like map to. So you like get two benefits out of it. One is that you get a DDoS protection, as in, let's say, if some hacker he bombards your system with a lot of requests. So Cloudflare would actually identify such kind of requests and then they simply like block it. And the second thing is like IP masking. So what is IP masking? If you are the user who wants to like access my system, you never get to know about like my IP address. It's only the Cloudflare IP address that you get to know it, because Cloudflare acts as a proxy in between. So these are like the two free benefits that you get out of Cloudflare. And in the process, again, I had like some challenges with respect to like configuring in the Geo admin interface, because there was no proper documentation in it. So I had to like go again with the trial and error phase. But finally, I was able to like succeed and expose, as in only allowing traffic that tries to access 443 port, which is nothing but HTTPS. Like whenever you access a website, right, you see HTTPS as a prefix. So that means you're trying to access the 443 port of that particular server. So these are like a simple basic screenshots of the Geo admin panel. And this is the Cloudflare admin interface. Yeah. Now, once the connectivity was set up, now it's time for setting up the software. So I'm like currently using image as my Google Photos alternative, and the image suggests to use Docker container for easy maintainability. So I had to like install Docker, and then upgradation was also like very easy. Just like pull in the upgraded image and then like run that particular container. So that was like pretty easy. And after like setting up the Docker, then I had to like install reverse proxy engine, which is like one of the reverse proxy engine is Caddy. Now why reverse proxy engine? Because even like after I set up image software application, which serves on a particular port, but again, what I'm trying to do here is that like one more security check. Image will be able to like only serve the local requests on the system, as in it doesn't serve requests apart from 127.0.0.1, but only serves this local post request. So this is kind of like security check, as in nothing external request will like come in, but it should go through this reverse proxy engine, which is Caddy. So the Caddy engine like acts as an interface between the external request and the image service. And yeah, again, like the challenges are like with respect to the image Docker configuration and Caddy configuration. But once that was like through, the system was in place. So this is a simple reverse proxy configuration file. So I don't know like if it's visible, but if you see with respect to that particular like domain name, it goes to that local particular like server address and port, right? So this is like how it looks. If I access like right now from my mobile, or if you access right now from your mobile, it's similar to like Google Photos, but it's like for free. You can use it. If you have a system, you can just simply like backup and then like see anywhere from the world. And on the left side of the screen, if you see, there's like this small.
Can I address any more questions? If there is any? Yeah. Just. Yeah. All right, guys. Thank you so much. Thanks so much.
Thank you very much.
Thank you.
Yeah, again, I think like, this T-shirt is probably the best tag for this meeting. I think it's offline. I think we can like, take a break now. Maybe me and some of us are in just a few minutes. The people who have laptops or maybe connected to the monitor can we please have a chat with you while they can run a scan network. We have 1, 2, 3, 4, 5 more talks. Is Javeed Syed here? Yeah, 6 more talks after the break. So I think from 5 to 6, we are going to stick to like a 10-minute long lightning talk schedule, and then we'll try and wrap it up at 6. Yeah, sorry. More changes of plan, like what is happening today. Balaji is going to do a talk. Balaji is our local host today. He works at StackNexus, and he's also one of the speakers. So Balaji, take it away and also please tell us about StackNexus.
I'll go to my laptop over there. Sorry guys, there's still like tea and samosas on the way up, so please bear with me. So my talk is going to be more of a show and tell. So it's more of show tell than oh, fantastic. Okay, everyone is able to see my screen. Okay, so probably grab my bag because some of it is. So I'll keep my talk short, bearing in mind. So there's nothing so big. So here I'm not going to talk about any software and stuff. So I'm more of a tinkerhead. So just to give a quick intro about me and StackNexus and everything. So basically, so StackNexus is an IT services company. We do Salesforce, mainly for US public sector and in Middle East as well. And I head everything that is data and AI here at Stack. So by background, I'm not a software guy. I am an astrophysicist. So I used to work for telescopes in Chile and in Spain. And then I started my own company, which is still running in Greece, FOPI Astronomics. So this talk is mainly around what we did with 4Pi and what all we open sourced with 4Pi. So it's not just the software, and we realized there was a huge potential with the hardware as well. So quick question around the room, like how many of you guys are tinkerheads, as in like DIY folks? Awesome, okay. I can see a lot of people. How many of you guys had your experience with 3D printing, CNC, machinery? Not much? Okay, no, I would really recommend you guys to try it because it's nothing so hard. I mean, I'm not an engineer at all. I'm a physicist, astrophysicist. I've never, ever touched anything that is of engineering. So now, well, here I am building things. So the whole idea about open source hardware is it's one of the least explored areas in open source. So, and it's most underrepresented. So have you guys ever been to T-Works here? T-Works? Anyone part of T-Works? No? Okay. If you get a chance, T-Works organizes so again, another promotion maybe for T-Works. So T-Works does a lot of, how do I say it? They do a lot of like show and tell kind of meetups where people can show their tinkers, what all they have built. And there are some pretty cool builds that I want you guys to see, and most of them are open source. They have all the files on GitHub, and you can definitely go and you can contribute to their projects as well. So that's the big one. So yeah, so I'll just jump into this. So essentially, like it's same thing as like it follows the same process, right? It's all repo as in like it's on Git repository and the source. I mean, in this case, source are just basically STL files and schemas and diagrams, maybe some object files, CAD files, and so on. Typically, 99% of them are STL files. Some guys can do it as .obj files. So essentially, these are some 3D objects which I'll show you in my magic bag there. So the thing is that these STL files, they can yeah, so they are printable. So you can go download your files, take it to any 3D printer around. Every town has it. If you go to T-Works, they have plenty. And say if you are serious enough, you can also invest in your own 3D printer. It costs around, mine was around 35,000. But yeah, you can. There are cheaper printers also out there. But if you want CNC, majority of the places always has some tinker place, and especially I would recommend T-Works. Been promoting them a lot, but it's not a paid promotion. But just saying, because I usually sit over there after work most of my days. So that's where like majority of. So if you have these source codes, and there are a lot of people who contribute into it. So have you guys ever seen Tinkercad? Okay, fantastic. Okay. So a lot of folks know about these Tinkercad stuff, right? So Tinkercad is not much of a collaborative place where you can just upload your stuff and that's it. But there are a lot of folks who have taken it to the open source, like GitHub and so on, where they have repoed all these things, and there are people who can contribute as well. So sometimes, like say for example, let me just show you a few, like one that I've contributed as well. So there are a few mounts as well. So for example, this is a mask for a telescope. Okay. So the whole idea is like, this is called the Duncan mask. And these were made for large telescopes, like 8-inch, 10-inch diameter and larger ones. So like this was one of my contributions. So it was like in the same repository. I'll show you the repository at the end. Where you, so basically like you put this in front of the telescope, and typically a telescope has like a primary mirror and a secondary mirror. And if they are not aligned properly, well, you don't get the most prettiest pictures ever, right? So for that, essentially this Duncan mask can take any broad light like this. It makes like 3 pasta shapes on your camera, which is stuck behind the telescope. And if you can bring all these 3 pastas together into a shape of Y by adjusting the position of the mirror, then you get the most prettiest alignment. So there are a lot of such hardwares, but I'll show you more. So, and in the astronomy community, there is like the entire open astrotech that's growing up. So if you like over here, you can see some of it, which is like top left, you see like a tracking mount. So basically, like if I have to shoot a deep space image, the Earth spins around at 1,400 kilometers an hour, right? So we need to track, counter off this motion, because if I'm going to point a telescope and look at it, I'm looking at a 3D tiny part of the night sky, right? So if I'm pointing and looking at it, within like a fraction of a second, the object is just going to zoom through my field. And I have to lock it in. If not, I'm not going to see the object, I'm going to see it playing around, right? So for this, there are a lot of trackers that counteracts Earth's rotation. So typically, tracking mounts, if you want to go for a good one, can cost you somewhere close to 1.5 to 2 lakhs. So that's where the open source community comes to help. So Open Astrotech is one such community. They're actually a company. So there are 2 parts to this. So this is like something that they call, and even at FOPI we call it decentralized manufacturing. So the idea is we open source majority of our parts. I'll introduce FOPI after this slide. So the kind of open source majority of our components, we want the community to contribute in there, collaborate in there, or even make their own builds. We don't want to get involved. But we will have our own proprietary from which we make our own money. Say, for example, a camera behind the telescope or a guiding system and so on. Whereas Open Astrotech, these guys mainly focus on tracking systems. So unfortunately, I wanted to show the entire tracker build, but all I have is just 3D printed components right now. Yesterday, I was waiting for them to like get me some of the belts and bearings that I was waiting for them to give me, but T-Works didn't have it yesterday, so bummer. So I can only show you these parts right now. But essentially, all of this assembles to what you see on the left-hand side, the 2 pictures. So this is, again, it's on GitHub. You can go to github.com OpenAstrotech, and all these STL files are there. So they have like the OpenAstro tracker. They also have the OpenAstro Guider, which is basically like again, like it's a 3D printed telescope with their own proprietary camera behind it. So it's not just in astronomy, there are other fields as well. So there is like, so the next one is like my other company, FOPI Astronomics. So we build, again, like we manufacture our own telescopes, and we have our own cameras, imaging cameras, and we have our own observatory dome sheds and things which can house the telescopes. So what we did is, last year, we partnered up with International Astronomical Union and made all the source files for this open source. So you can go to our 4x-Astro. Not all the repositories are out there, but we will soon release all the STL files in there. And all of these are open source, right? The telescope builds and stuff. It has also, like, even Open Astrotech, they have their own wiki. We are creating our wiki on how to, like, put it all together, because, if you go and download the STL files and print, you get something like this. So how do I put it all together? So there are wiki instructions and so on. And there is a huge community on Discord, GitHub. They contribute into all of this. And it's not just in astronomy. I've seen until like the last, I think 2021 was the last time when they were active. There was also another active community with ham radios. Right? Anyone into ham radios here? amateur radio. Oh, super. So there were like, at least in the early 2000s and when I was active in ham radio, a lot of people used to make home rigs. So these home rigs are, again, DIY at home, built simple receivers, HF, VHF receivers, where the schematics of like the circuits, like every single thing is like shared. But back then they didn't share it to,
This is even related to Rajkumar said, one of the NASA satellites, they have a image of a ray or something.
Yeah.
They're sending to a radio signal. So
Yes.
you have a radio signal, you can actually convert that analog image and your digital, and you can have your digital image of your downloaded.
I didn't know airport actually had a radio. Okay, but that seems to be. But there is something called airport astronomy picture of the day that NASA releases every day. So yeah, I didn't know. But if you are like into tinkering around there, you can try. But although in the last say 4 or 5 years, the home rig community for ham radio went down because there's a lot of SDRs right now, the software-defined radios, where you don't need to build all those mixers and RFs and so on, right? So you don't have to do any of those electronics anymore at home. Like there are SDRs these days, and they are also open source again. So that's why I didn't include that in. But there are other open source as well, open source hardware manufacturers. For example, these guys like on the top left. This one is. It was called Axiom. Axiom, they have a complete open source camera. So their build and everything is out there. And the chip is typically, Sony IMX290 or something like that, which anyone can buy it off the shelf and you can assemble your own. So, and of course you have Thingiverse. OpenRave is an open source robotics community as well. And they have simulators, but the community also has some builds that they share around. So I couldn't bring too much because the entire open source hardware community is not as big as open source software. But I mean, I just wanted to bring it out. But yeah, that's pretty much my talk. And if you have questions about whether StackNexus or Drupal.
How do you do it? Is that like you need to have connections in
No, not exactly. So that's what I initially thought. But T-Works, they have programs. So right now, I'm part of their maker program. They charge around something like 3,000 rupees a month.
So you can get access or what?
Well, you need to pay for it.
Okay, yeah, that's fine. But I looked online, but I tried looking it, so you can't find it.
No, you can.
But we can, I searched some website, rent is like $5, shipping is $25 from NASA.
No, you don't have to ship, right? Because you can just drive down there or just go down there to T-Works. And if you go and talk to those guys, or you can reach out to me, I can take you to T-Works and let you know. So, I mean, I usually hang out over there often, and they have this thing called Maker Program, where they give you exclusive access to certain parts of your machine. But even if not, if you just go there and talk to the people over there, they are super helpful to help your things. So, yeah. Oh yeah, this is like another mask. This is for a telescope again to focus. So there are like 3 angles of. So this was one other repository that's there. This one is called the pattern of masks. So this helps you to focus objects. So all these are open source, guys. So you can go to GitHub and download it. Okay.
Thank you, Balaji. Again, all the speakers are going to be around, so you can talk to them during the break. We're going to take a break now, so there's tea in the meeting room. There's also samosas in the meeting room. We'll take a half-an-hour break, so we'll come back at 5:30. So Balaji gave a talk. Henit gave a talk. Akhil gave a talk, and who am I forgetting? Yeah. Huh? Yeah, she's not. But so if you want to interact with any of them, they should be around. So please do talk to them. Apart from that, can the rest of the speakers please stand up? Prasun is one of the speakers. Arya is one of the speakers. Yeah, sorry. And Javed and Sudeep. So all of them are also speakers, and they're talking on a whole range of topics. So you can also interact with them to get to know what they're talking about next. And yeah, we'll come back again at 5:30, and we'll try and wrap up the rest of the talks. Thank you all. I think I'll say this again at the end of the call, but I do want to say that hopefully doesn't mean learning experience for a lot of you. Hopefully, I think we have
Srujith. Okay. Nice to meet you, Srujith. Open source software on music production.
Music production.
Yeah. Sure.
From just here. Yeah. Okay. Is it your audio and mic? And we can just use this. Or we can use your mic. Yeah, actually. Yeah, sounds good. Um, is it? Is my screen visible? Yeah. It's visible. It's visible now. Yes. So, hi, my name is Arya. Today, I'm going to be talking about Gitea, which is, have you like, I'm sure a lot of people would have used GitHub, which is owned by Microsoft, which is a very good code hosting platform where you can store your source code, build your application. Uh, you have GitHub Actions with which you can deploy automatically. But what if you want to do it by yourself? What if you want more freedom? What if you want more options and flexibility? And also you want to learn more of how it works. That's where Gitea comes. Gitea is basically a GitHub alternative built with Golang. It's very high performant tech side. I like to play football. I am learning skateboarding and I do a lot of art, which is why the first slide was my hand-drawn thing. You can connect with me on LinkedIn and other places. And getting back to Gitea, I'm going to show you uh, how it looks. This is the interface that you have. Gitea is very similar to GitHub, meaning there is no transitional knowledge that you need to have. You can just get started using it. To host it, I'm using DigitalOcean, which is a cloud service provider. It's like AWS, it's like Amazon, it's like Google Cloud, but it is way more cheaper, way more easier to work with, and it's easier to approach. You don't need much. For me, I'm just hosting everything on this one server, which is running Ubuntu. It has 4 GB of RAM, 80 GB of disk, and it's hosted in Bangalore, meaning that I have very low latency because I'm using here. I don't want to host it anywhere else. And the service is running in a Docker container. As a Docker container, I manage everything via Docker Compose. So this is the actual usage of the server. As you can see, like very minimal. I have so much headroom. I can run 10, 15 more services, 10, 15 more application. Even I can deploy plain here. I have a proxy manager which manages everything for me, and the UI, I have a GUI for it. The name is Nginx Proxy Manager. This is how I manage. With like, as you can see, there are two domains. One is for the admin dashboard of the proxy server, and the other one is the Git, like Gitea instance. So I can easily manage. You can see the domain, which is mapped as a destination, which is Gitea port 3000. What it is doing is, I have a global backend. The network itself, there's a unified network to which all the Docker containers connect. It's like, let's say that computer, this computer subsat me. And then what I do is I can spread apart all the services, different containers, and then I can still manage and connect with each other without any issue. And I use DNS, like Docker has an internal uh, uh, host names which you can just call. I don't have to map an IP address. Even if the container IP changes when it's restarting, I don't have to worry about it because Docker takes advantage of that. Why not Kubernetes? Because it's complex and I don't have to use it. The only reason that I use Docker is it's simple. At the end of the day, you use a tool that makes it possible for you to get the job done. It's not for showcasing to others. It's not for learning. It's good, but then if a tool is overwhelming you, you don't use it. That's what I follow. That's the mantra that I follow. And Gitee, the reason, like, okay, now why Gitee? Why not just stick with GitHub? You don't have to use your own server. It's quite easy to, like, there's no management because it's a hosted service, software as a service. But the thing is that how many people here like to crack software? Like, have you guys used a proprietary software where you had to activate it and you had a script that you found on GitHub and then boom, it's gone? YouTube, for example, YouTube DL. Let's be very corporate friendly here. YouTube DL was taken down by GitHub because a lot of music companies raised a DMCA complaint and the tool went down. Now, YouTube DL is a piece of software which lets you download videos. It's not illegal software because all the videos which are public on YouTube are licensed to be, consumed anyway that you want. And unfortunately, GitHub got the request and they got it down. Now, if in this case, if you had that code base which was getting mirrored, which was getting synced in your own server, then you won't lose the access. You will still have the access. You can still continue as if nothing happened. That level of control, if you want, you have it. If you are using, like, if you're a small company, you have a lot of proprietary data, a lot of internal projects that you're doing. And if you have for this, it does not take, you don't need a lot of operational experience. You can learn on the go. It is very easy to manage. It's very easy to deploy because of Docker Compose. I will share the Compose files on GitHub later and Gitea as well on my own instance, obviously. So you can check it out. Why the control, right? Why is the reason of why is the control, and what are the features? It has feature parity with GitHub, meaning that everything that you have on GitHub, you have it here. You have the code view, you have the issues, you have packages, projects, releases, wiki, and activity. But then another thing that I wanted to focus today is actions. How many people have used GitHub Actions? Awesome. So GitHub Actions is, with GitHub Actions, you can build and deploy stuff. And I was about to use Drone CI today, but I changed my plans. I'm not going with Drone CI because I realized I should follow the funda that I'm telling. Like, always use stuff that just enables you. Drone CI is amazing, but it has its own overhead. You have to deploy a runner server separately and stuff like that. I'm using Gitee Actions, which is basically GitHub Actions ka code base pe they have improvised and they have modified it to be integrated with Gitee. And what it does is it has feature parity with GitHub Actions. There are some actions which are not right now supported, but most of them are supported. And what it can do is you can build stuff. These are the test things that I was trying out. You can see all the steps that it has done. This is literally running off of the same workflow file template that GitHub uses. Yeah.
The UI and everything looks very similar to GitHub file complaint or something.
That's the thing, right? The UX.
If you just remove the logo, I cannot tell from here.
Yeah. The thing is that Git underlying the protocol itself, right? Proprietary stuff has been built on top of it. UX design choices are their own. This is a theme, by the way. You can change the theme. You can completely make it custom. You have the option.
I'm telling, like, do we have the same fear as we had with Utopia?
No.
GitHub says this is not.
No. So the thing is that GitLab is there, right? GitLab has a bit of different look. This is basically built for people who just want to try and manage their own things. And so far, as far as I know, the UI is not a problem here. There will be no conflict here because, yeah, it looks similar, but it's not exactly the same. And obviously, we all are building on references, right? Nobody has the perfect unique idea. Everything is always iterative. And if everybody like GitHub is like, oh yeah, this design is mine, karke pakad ke baith gaye, it becomes an industry standard. It's a big problem. That's why open source, we are promoting open source so that that does not happen.
I mean, just for example, there are apps that you can install on Android that make your phone look like an iOS, right?
Yeah.
Those aren't illegal.
Yeah.
Like, but it's basically making your phone look like an iOS, and if Apple isn't coming and suing you, I don't think GitHub is going to come and sue you.
The thing is, trademark violation is serious. If they use anything GitHub code, any GitHub code, or any logo or any trademark that GitHub has, if they use it, then they will have a very big issue. They don't use it. This is a custom built from scratch, a service which is very similar to GitHub. But the greatness here is that it's very, very cheap to run. I deployed this a couple of days back. That's it. Yeah.
Do we have any restrictions on, like, I think GitHub Actions has for free account?
This does not. You run the runner. You are owning the runner. You can scale it up. You can remove the runner if you're not using it. Remove it. And okay. Now that we have talked about GitHub, I want to show you something because if I go to a new tab, is it visible? Now, white tab, Ara. Okay. So let's see. So as you can see, I have a single sign-on enabled on this. So I can log in with GitHub. I can log in and manage my own server with the same credentials that I use on GitHub. Meaning I don't have to worry about any new passwords. I'm going to upgrade this version. I got to know that they have added a new feature which is passkeys, meaning that I can use my Touch ID to log in. I don't even have to use the GitHub login as well. Like,
let's say if I have to use the CLI, GitHub now asks us to use the security key, right?
yeah, it has support. It has two-factor authentication enabled right now. It's skipping. I have made it a config option where I can skip the 2FA authentication if I'm using a third-party SSO. So because I'm using a double like multi-factor on my GitHub, so I don't have to have multiple here. I'm logging it with a third-party trusted authenticator provider. So I have chosen to just skip it completely, right? And the funny thing is, like not funny, the disastrous thing is, until last year I had so many services which were running on my own servers. I had like a couple of servers distributed across the world. I did this for tinkering, just to learn more, and I learned why you need SSO. Because it's a pain to manage all the accounts and services. I use password manager, but can't login. So I had deployed my own Keycloak server, which is OpenID provider server. With that, I could access all my services. Portainer for Docker monitoring. Keycloak has the main sign-on. Drone CI, Gitea, Bookstack, like all the services that I was hosting, everything would have the single sign-on, and I had the option to build my own login pages if I want to get the unsupported apps on the. But most of the applications do support custom open ID authentication. So that's like I have tried. I'm really happy to know about Plain. I've tried Taiga, which is built on Python. It's really amazing. I like the UI. It is also open source. Yeah, it is also open source, and it also runs on Docker container. But it's not as easy. That's what I wanted to highlight. Plain is built such like I am really happy to come across Plain today, especially a demo, because the amount of focus that has been given for the user installation and user deployment is just on the next level. It's like Mac kind of Apple-like experience where it's one touch, and it's really one touch deployment, unlike other service providers, and that's a plug. So yeah, that ends my talk abruptly because I don't want to extend it further unnecessarily. But at the same time, let me see if I can wrap up with.
Can I ask you a question?
Yeah, please.
Does it
So for me, I had a startup last year. I got credits. I got funding for running all the my services and development projects. So it's getting deducted from that, but it's around $25-30 if you don't have the credit. But you can go for a lower version for this per month. Yeah, you can go for the lowest server actually. I went for a beefy server because I can host more things and I can have demo access. If you all need it, I can have a demo access so that it can manage all the users. It has a reverse proxy, so I can enable caching on that so that all the assets that are already there on the server will not be reloaded from the server itself. It will just be served directly. I'm not using Cloudflare because I don't have to use it. If I don't mind having a DDoS attack because it's a test instance, and DigitalOcean also has an inbuilt DDoS protection service. So a lot of smaller providers have inbuilt. OVH is a really good one because I used to have my servers on OVH, Canada region, and they would offer DDoS mitigation for free. AWS charges a bomb. AWS is so expensive if you are running any of the services. So I would recommend if you are trying out something, go with any smaller provider, Volta, OVH, or DigitalOcean. Linode became Akamai, so I don't know. I don't have much trust in them because they are a big provider now. Any other questions? Okay. Okay, thanks for the opportunity to present. And yeah, reach out to me at any time. I will share my LinkedIn. And hope to see you guys again in next event. Yeah, I noticed.
So a few more changes. We actually need to vacate the producers at 6:20. So the few speakers who will not have as much time, I still want you all to introduce the topic, but then we will reserve a slot for you at the next meetup. So I hope people will come back again. Arya, thank you very much for giving the talk. Arya is a familiar face in the community because he was here at one of the first meetups that we did, and it's great to see him back again. And it's good to see you back again. And then thank you.
My screen being shared. Screen share. Hi everyone. So my name is Prasun, and I'll share with you my project called Zasper. So Zasper is a supercharged IDE for data science. How many of you have used Jupyter? Nice. So yeah, you love this. So right now Jasper is trending on GitHub. Like for this week, you can. It got around 1,400 stars in last 1 week. So what is Jasper? It's a modern IDE built from scratch in Go. It supports massive concurrency and helps you handle numerous concurrent connections. So by concurrency, I mean that multiple tasks can be run on a processor, and like they are scheduled, and then you can use then you might be knowing that some tasks are IO bound and some tasks are CPU bound. So this IO bound task, you can schedule them and then you can run them. And Jasper has a unique feature called it has a minimal memory footprint with an exceptional speed, and it is perfectly suited for running REPL style data applications. So what is Jupyter? So when it was announced, it was number one on Hacker News on 2nd Jan. So Jasper is I did some initial benchmarks for running Jupyter notebooks on Jasper and compared it with JupyterLab, and it turns out to be 4x better. So let's say if JupyterLab takes around 104 MBs of RAM, like in a basic state when you have two notebooks open, like two tabs running two notebooks, and then at that point of time, Jasper just takes 26.7 MB of RAM and 0.2 CPUs, and so this is where the major gain is. So this is why I used Go to build this project. So this helps you utilize all the cores of your machine. And uh, sorry, I'm all over the place because I'm giving this talk after a long time. So what happens in Jupyter? Let's go into deep. So as you all know that Python is limited by its GIL. So if you are running a Python process, it can only use one core. So right now the Python community has built a new Python compiler interpreter that helps you get rid of GIL and scale to multiple cores. But at this time, I'm not sure how good they are at production. So how Jupyter was built is like they use something called a Tornado server. Like right now, you might have heard about Fast API. So Fast API helps you run everything asynchronously. But at that time, they used Tornado because Tornado was the standard then. Tornado was built by was a startup that was acquired by Facebook, and they built Tornado. They used Tornado to show the feeds on your screen. Like if you open Facebook and the main wall, that the Facebook wall, so that is run by Tornado. So asynchronously, it helps them create multiple connections and then serve those requests. Plus, there is something else called Jupyter uses something called 0MQ. So this if you all are you want to get into open source, and so there is a chance that you will hit closed source software. So read this book by Peter Hentzens called Code Connected and How 0MQ works, and then it will give you a lot of idea what the enterprises are not showing to you. Like your Wi-Fi has a lot of potential. You can build P2P apps. So right now, like everything, like Spotify, all these apps, you are forced to use the cloud. But multiple things can be done on a network, P2P network, something like that. So I'll suggest that you all guys should read this book. And 0MQ Peter Hinjens and the community created something called 0MQ and helps you do a lot of magic. So it helps you create small sockets on your machine, and these sockets are networked together to pass messages real time and very fast, and they are very lightweight. So uh, this is how Jupyter was built. Now this main part, how you handle multiple connections, how you handle multiple sockets. So this was done in Python using Tornado plus something called async IO. So async IO is something like an event loop. You submit the tasks to it, and the process gets executed, and you get the output. But the major thing is it's still one core. So that's why I built it in Go. So Go helps you scale to all these multiple cores. And if you see the programming paradigm of Go, so it is built for concurrency, like coroutines. So this helped me, like I took everything, rebuilt it in Go, understood saw the intricacies of Jupyter, and then this was built. So yeah, this is the story. So if you see the architecture, like this is a lightning talk, so I'm not going deep into it, but this is how it looks overall. Like as you see, there is a Jasper server and there is a Go backend in Gorilla and there's a React frontend. So the user interacts with the React frontend and the magic happens via Go backend. And then whenever you create a notebook, it can help you create a Jupyter kernel, and then you connect with it and you do your computations. So yeah, I'm something of a data scientist myself, but not really. I'm someone who is an engineer and a DevOps guy. But I knew the problem. Like I have been building data, software for data science for a long time. So yeah. So you can find me here on Git. Put the links for GitHub, blog, and Twitter. And this is the project link. Like I would say, I would you like if you guys seem interested in the project, you can join. You can take a look and try it on your own. I'll show you how Jasper looks right now. Small demo. Can you see the editor? So this is how Jasper looks right now. Looks like right now. So it's a proper ID. Like let's say I write ls. This works. You can do anything like curl google.com. Okay. Now it supports files. Let's say I run open app.go. You can see it here. Then the main part is like running Jupyter Notebook. So this is the how the front end for running Jupyter Notebook looks like in Jasper. Yes. Last one. Okay, so I don't have enough time. Just I'll show you that if you run it, it runs. uh, then it supports all the data formats like charts, pyplot, everything. Okay, there is an error because I didn't import NumPy. Okay, so this is an interactive REPL kind of notebook. So in the future, and I'm trying to make it more stable so that different everyone can use it. Right now it's only like it has full support on Mac, and then just Python like only one environment in Python. Like it will later be configured to run different types of Python environment. So yeah, the road is long, but yeah, that's all from me. Thank you.
Thank you very much, Prasun. I hope people got to talk to Prasun during the interaction session. I'm gonna nag you to come back and give another talk at the next meetup. So hopefully other people also join the next meetup to listen to him again.
Sure. Thank you. Thank you.
Javeed is going to quickly talk to us about Typesense, and then we'll wrap things up after the next Typesense.
Have you looked at
Typesense. But Typesense has its own another backend service running. We can hit that backend from our front end. So and it has a one like it can auto scale on its own. So so it is internally it uses NoSQL DB to do the searching process. So in if we are using like NoSQL databases like MongoDB, there is one function called text search. So it implements a fuzzy search method internally to do the searching to optimize the search. So at around up to 1 million documents, we won't feel any delay in our result. It will be within 1 second. So as the application progress, as we scale up our application, the MongoDB cannot handle that much complex queries. So this library Typesense, so MongoDB is basically built for CRUD operations. So this Typesense is only built for optimizing our search queries. So I got to know this library when I was searching for a problem. In our company, our project manager told to decrease the delay of the search. So at that time, I got to know this Typesense library. So by using this library, we can delay our query, and we can also use in AML applications. And in our if we are creating any like websites, we can embed this in our websites. So thank you, everyone.
Thank you, Javeed. And for our last talk, Srujith, please take it away.
Anybody? Well, watch the screen off. Yes.
Can you stop sharing? Yeah.
Right? Yes? Yeah. So I'm Srujith. I'm like the most non-tech guy you can ever see in this whole room because I've done my engineering in food technology, and I've been a full-time musician and a part-time IT employee now. Like very, very out of the box. So I'd like to expand on my views on open source software in terms of music production. Okay, so I'll just start with what music in general is. Very simple in short. So it's music is a tune and beat. So it's a combination of tune and beat. Okay, so we have softwares which we have open source softwares for that, which are Audacity at the first place. Anybody have heard of Audacity? Right, good. Yeah. So Audacity is a software which helps you edit audio forms. Okay, it's like you can manage it and you can place it in specific bars and etc. Right? And yeah, and wrap it up really fast. Okay, so that later in the next meetup we can make it even bigger talk. Okay, sure. And the second thing is search. Anybody have heard of search? And by the way, any musicians in the room? Guitarist, anybody? Nope. Yeah. Cool. It's
Wrong
okay.
place to be asking the question.
Yeah, okay, sorry, my bad. So yeah, search is a synthesizer actually. So it's an open source synthesizer which allows you to make tunes. So the tunes part of it, okay? Tunes part of the music. And the second thing is, FabLa. FabLa is an open source software which uses beats. So yeah. And the last thing, LLMs. So this is an open source digital audio workstation where you can like combine this synthesizer and as well as this FabLab, so which you can like tune and beat together and mash it up and place it on one place. And this is a simple interface that's being shown over here. And later, once in the next talk, we can actually make a whole live beat here at FOSS. Okay, right? This is a simple interpretation of how the MIDI notes are mapped, so that you can like place it in even times and then play the music, play back the music in general. I'll just maybe if my audio is like clear, I'll just play a small track that I made using this software. Okay, give a minute. I guess it's not audible. The whole thing is made up with the open source software. Right. Thank you guys. Thank you. So next meetup we'll just make a live beat over here. Thank you.
I've seen a lot of good lightning talks. That was a great lightning talk.
Thank you. Thank you so much for giving me the topic.
Yeah, thank you all. It's going to be an abrupt end to a day. Nitish, do you want to say one thing about ICANN? Yeah, just like. No, once again. This is how I would like the Hyderabad chapter to be. Musicians, CAs, people who don't usually end up at meetups like this, but actually end up contributing meaningfully to the community. So please.
1 minute. So I will talk about the policy meeting.